production issues. We've heard about disease issues, and I guess the next thing is to figure out how we're going to harvest and transport and process the biomass that comes out of here. And so the next two speakers will actually talk about more of the harvesting and other logistics issues with short rotation hardwoods. So Tom Gallagher is the first one, and Tom will talk to us about harvesting challenges and how we might harvest these trees in another year or so. Tom is an associate professor at Auburn in the School of Forestry and Wildlife Sciences, one of the forest engineering group at Auburn that works on harvesting and other forest operation issues. So, Tom?
Thank you, Steve. Steve, we have a really good group down at Auburn. We have a collaboration effort between the biosystems engineering folks, which is Steve's the department head of that, and so that's the true forest engineers, and then there's the folks in the forestry school like myself who are kind of the operations people, and we even have the USDA Forest Service group is based in Auburn. So the three of us collaborate a lot on this research stuff, research ideas that we're having on the harvesting and logistics side. Tim and Steve gave a really good introduction, but since we're talking a little bit about logistics, I always want to make sure everybody understands what's going on here. This is a broad collaborative effort between several universities and private industry and the government in terms of trying to make it economically feasible to bring fuel to market in one form or fashion. I want to make sure everybody understands that. I have to make sure my students understand that. It's not, can we make fuel? We know how to make fuel, right? We've been doing it for 50, 60, the Germans made it through World War II making fuel from wood. The problem, the challenge is making it economically. Can we do it for $3.05 a gallon, whatever that number is out there? And so now the research has become very holistic. It's become where it used to be a bunch of individual entities. Now you have the people that are involved in growing the trees are getting together with the people that are involved in maybe harvesting and moving the trees with the people that are converting the trees. And I like to kind of bring it all together in a simple phrase. It's called stump to pump. Okay, we're looking at the whole picture and making sure that we can do it efficiently, economically, to make sure that there's an economic return to the people involved. So my side is the harvesting and logistics side. I tell people when I have to stand, you can tell a little bit of Yankee in me, and we have to hold the microphone. I have to feel like I have to talk in one syllables because I'm so used to using my hands. So our portion of it is we're looking at how to harvest the material. Rick mentioned it a few times, the stump harvester, the short rotation harvester head that they experimented with. It was actually started with New Holland, and they started it on willow up in New York. They had willow crops that they were harvesting, and they then took it out west and tried it on poplar, and it is a great machine. It'll harvest a lot of volume. It runs through a bunch of small material, but it's important to understand that it chips it at the stump. So it chips it out there, puts it into a bin, the bin goes out to the landing, and you put it in a truck and take it to the market. And they do it very efficiently. And if the material is only that small, that's great. The question mark is the challenge to that is it's very difficult to dry chips. It's just, chips don't dry very well. They lay in piles, and the first 3 to 4 inches dry really well, and the rest of it stays nice and green. So if you want to dry the material, the short rotation harvester as we know it from New Holland isn't the answer. So that's kind of where we got involved, and what other answers and alternatives do we have to make this economically feasible. So we're looking at other ways, alternatives to harvest the material. One of the things that we want to do is understand, what are the limitations? Because there was a lot of question marks as to what the limitations are. So that's kind of where our study started, and you can see my poster didn't make it through the wind, and I said if I put it up it would just blow down again, so I left it down for now. I'll put it up at lunchtime if anybody wants to check it out. We put together a study to evaluate the two kind of variables that we can think about, and one is season. Can you harvest in the winter and the summer? We're used to it. We have a great logging force in the southeast. I just got back from a meeting in France last week where I was dealing with forest engineering across the world. And in our discussions and in some of our research, we have the cheapest logging rates in the entire country here in the southeast. We do it better than anybody else in the world. Okay, we have good ground conditions. We have good, it's not too hilly, it's not too wet, it's not too steep. All these good things. We have the cheapest logging rate. So if you grow a tree 6 or 7 inches and anything bigger, We know how to get that out efficiently. The pulp and paper industry has been doing it for 50 years. We know how to, no question mark, I can tell you, we do it every day. But now you're starting to change the crop. Now you're starting to deal with stuff this small, and you're dealing with it. How do you want it in the final product? Do you want chips? Do you want roundwood? Do you want it clean? Do you want it dirty? Do you want it with leaves, without leaves, with needles, without needles? So there's a lot of variables in there. So one of the big question marks is season, winter versus summer. Now you have a crop. Previously, we always had a crop that once we mowed it down, either natural regeneration through root sprouting or through replanting, we were going to get it back. Now you have a tree that you want to have come off of that stump. You want it to coppice back out. So what happens to that stump is really important in the harvest practice. The other thing that was involved is we know how to do it cheaply, or what we know what kind of equipment can do it effectively. You have saws that cut a tree, but you also have shears, which are a lot cheaper to purchase, a lot cheaper to run, that can, basically pinch a tree off. And so we said if we could go to shears, we could cut some of the cost down, better economics. So we put together a study doing that. I'm actually going to concentrate. We actually studied eucalyptus and willow and poplar, but for today, I'm just going to talk about just the poplar. If you want to read more about it, we have some eucalyptus plant plots down in Florida. The poplar, the cottonwood sites are in Arkansas and Mississippi, and the willow site was in Mississippi. So we looked at a study. We said we're going to do a winter cut and a summer cut, and then we're going to see how they coppice back. We also did it with a shear versus a saw. And again, the poster, you can look at a shear head. Again, it's a big machine. It's like a pair of scissors. It just pinches the tree off. So that was one of the alternatives. And then with a saw, we have a circular saw in industry, but for this example, we just use a chainsaw. And these are some of the results we have for the winter harvest only. We actually did the summer harvest in May and June, and we're going back to the site next month. So the first one, let's start with, I got one here. Let's start with the Estes, Arkansas site. This was a site just below Little Rock. They put a bunch of cottonwood in the ground 3 years ago. And as you can see, first of all, what's not on here is in terms of survival or coppicing, we got about 99% coppice back from the first cut in the winter, from the quote-unquote winter cut, which was done in late February, early March. It was still before the leaf came back out. And we got 99% survival. I mean, every tree came back out of the ground, coppiced right back, no problem. We saw a little bit of variation between the saw and the shear. You can see that the saw had about a little over 2 stems come out of the stump, whereas the shear came out with about 3 stems. We're not sure if that's good or bad. I mean, the idea that if it's only, I think ideally we wish only 1 stem had come back out. We definitely want 99% come back out of the ground. But ideally, maybe 1 would have been better, and that it puts all that growth on 1 tree. Randy's shaking his head. It depends the final product, though. It depends on the final product.
You have more chance for 1 breaking off at the stump, and later on as it grows. And so if you leave 1 only, then you have lost that individual yield.
Okay. Well, we're going to go back in 2 years and see what competition has done to taking these down. Okay, so it's a longer study. Okay, you'll go with me. Good.
We'll throw the beer on it.
Okay, so we're looking at the stems, and you can see the slight variation between shear and saw, but in this case the shear was actually better. And again, like I say, we like shears just because from the standpoint of they're cheaper to run, cheaper to purchase. What was interesting, you see the stump diameter. It was a 3-year-old poplar stand that had been planted. It did not look as pretty as this. It was actually an 800-acre plantation on the Arkansas River. They didn't do very good weed control, so that you can see the diameters. The stump diameters went from anywhere from a 1/2 inch to 3 inches on this 3-year-old stand. So it had okay growth in places. It was kind of up and down. So you can see the variability in diameter. What was interesting to learn was how many more sprouts came out of the higher diameter stumps. So that the solid gray bar there is the number of stems in each diameter class. So you can see the average diameter was in that 1.5 to 2 inch diameter. It went from a half to about 3.5. But what's interesting is the dashed line is the average number of sprouts, and the smaller diameter stuff only came out with one, mostly, generally. But as you went across, 1 and 2, but as you went across and you got into larger diameters, you found 4, 6, and 8 stems coming out. So we're seeing that diameter of the original stem is going to have an impact on what kind of sprouting you get back, depending on how many you want back. Randy likes a lot. The interesting part I'll tell you about this, yes?
Were there a range of clones? Was it one clone? What do you know about the plant, the material?
We were only doing a 1 acre plot, so they were all the same clone.
Okay.
I think he has 4 clones on the site. But we kind of had to shop around, and we, because of this, what we were doing, we picked a spot where we could work with 1 acre, and I believe this is all one clone. This was his better looking stuff, though, of the 800 acres. So I can tell you that. There was comments made about the second rotation coming back, and what surprised me is we went back to this site. You can see, keep in mind this was 3 years old, and we went back and measured this 6 months later, which is just a few weeks ago. There was a significant number of stems that were 1 inch in diameter and about 15 and 16 feet tall in just 6 months. So that second rotation, it said the root base, the root system is already down. So when you look out here and you go, this stuff's not doing much, it really is. There's a lot of, it was first time I saw it firsthand where that second rotation, because the root system's on the ground, really does. And you're going to see that more than, like I said, in less than 6 months, right at 6 months, we had more than 1 inch and 15 and 16 feet, some 17 and 18s on many stems. So that second rotation was obviously much better than that first rotation. So very good survival. The other site that we went to, Randy actually mentioned that it was a small plot they had down at Stoneville, Mississippi. This was actually 6-year-old poplar, cottonwood. I keep saying poplar, cottonwood. And you can kind of see the same response. Again, we had about 99% survival, 98 or 99%. I don't remember the exact number. So we again from the winter harvest. Let me clarify that winter harvest. These are all winter harvest results. Shear versus saw, very little variation. A little over 4 stems to 5. You see that a lot more stems out of the ground, but that had a lot to do with the fact that you had much larger diameters. It was 6-year-old material. It had some gaps in survivability, so the trees per acre wasn't quite as high, so therefore you see some really good diameters from stuff down at 1 and 2 inches, but we had stuff all the way up to 11 inches. Same kind of deal. You see where you had a lot more sprouting from the larger the diameter of the tree. So we're seeing that tree diameter has an impact depending on how many years you wait to do the rotation, and we'll go back to this in a couple of years and see if that number of stems from competition drops down or where it's going to stand. I will give you some preliminary. We didn't get around. We cut the stuff in June. Was this quote-unquote summer cut? Late May and early June. So we're about a month from going back to the site. On this site here, we happen to be on the site when the summer cut was 3 months old. And one thing that we noticed right away is the summer cut is doing very poorly on both sites. The summer cuts are doing very poorly. And so I'm going to say preliminary, very, very preliminary result. And when I say poorly, I mean less than 50% regeneration. So very early in what I'm saying, because I want to go back and check it to give you real numbers. But it appears that that's going to limit you to a winter cut. To get this stuff to come back out of the ground, which you want. You want to get that 5-6 rotations. It's going to limit us to a winter cut. Maybe a mid-November to mid-February cut. So that's that. Now think about, again, I'm on the harvesting and logistics side. So now you got this operability situation. First of all, we all know it's winter. We have wet conditions, so that's going to limit what we can do. You try to harvest this site in January and February, you may be sinking up to the axles, and that's not going to help you come back. So you have a crop out there that potentially is going to have limitations on when it can be harvested. So that limits when you can harvest it from an operability standpoint. It also limits the cost of those machines. Okay, yeah, I can figure out I can harvest this economically with that short rotation harvester from November to February. who's going to pay for the other 8 months of that machine? You know, we can't afford to run machines on 1/3 time. You know, at least we can, but it just makes it very difficult. So those are some of the issues that we're dealing with as we go through the harvesting and production and transportation side. We have some other projects that we've done at Auburn looking at transportation. How can we figure out how to put more trees on the ground? You know, other things like that. More trees and trucks. Something else just jumped into my brain what I wanted. So the reason we're doing all this research is because of that idea that, you know, maybe the short rotation harvester won't work as like we think. You know, it can only harvest in a short window of time. What can we do with it the rest of the year? A lot of this research here is a prelude to the idea, what at least what I envision, what some of the researchers at Auburn envision, is maybe the idea that we can build just a harvesting head. And we can work with our current very good logging force. And we can bring them in, and they, you know, where they spend 8-9 months of the year harvesting that kind of material, because they got a big fella buncher with nice wide tires and a saw head on it, because that's what you need to cut something that big. But maybe we come up with a $50,000 harvesting head. You know, $50 is a lot cheaper than a $250,000, or in that case, the short rotation harvester, I believe, is quoted at about $500,000. So if you can do it with a $50,000 harvesting head, put it on the same front of that other fella buncher, use the same skidder, and you can bring a normal everyday logger out there. He works on short rotation crops, harvests this stand for, you know, maybe January, February, 2 months, and then he goes back to roundwood, and he's working year round. The machines are working year round, and that's going to obviously make everyone more economical for the situation. So that's kind of where we're heading. The idea of designing a new head. So that we can, you know, have flexibility into which way we go, when we harvest, how often we harvest that final product. You know, again, a short rotation harvester is making just chips. Okay, we develop our own head. We can leave it in roundwood form, maybe get the benefit of transpirational drying. I don't think anybody's really brought up the idea of transpirational drying. Leaving it in the field, let it dry. You can take that 50% moisture content down to 30%, give or take, in just a few months, just a couple of months. And that's a huge benefit. That takes the energy value of wood and almost doubles it. So you can get that benefit by letting it dry. You can't do that with chips. You can do that with roundwood, you know, solid material. So get the advantages of that. Designing a new head gives us a lot more flexibility, which should allow us to make the whole situation more economical, which is something that we have to deal with as we deal with this, again, this stump to pump analysis on how we're going to make bioenergy work in the future. Questions?
Are these per acre figures?
Yes, this was, well, actually, it was really just our plot, which was, in this case, it was you're looking at a half-acre plot.
Okay. And how many acres on each of these?
We did 1 acre. So we did a half acre in the winter and a half acre in the summer, and then we cut that, so it's a 1/4 acre of winter saw and a 1/4 acre of winter shear, and vice versa. So you can get tree numbers. The Arkansas site actually was planted. It was a double row planting. There was 6 feet between the wide rows and 2 or 3 feet between the narrow rows. So they did 2 in this large, and then the spacing on the trees was like 30 inches. So actually, there's quite a few more trees on the Arkansas site, but they were basically in the 1 acre plot size.
How many total acres were planted on each of these?
The Stoneville site is, and Randy knows more about Stoneville site than I do. It was a small plantation back along the creek on the back side of the property. So it was actually, we cut the whole plantation. It was something they were all kind of trying to get rid of. And there's willow next to it. So if you look at the site, the board over there, it'll talk a little bit about willow. We did the 2 of them side by side. The Arkansas site, it's surprising a lot of people don't know about it, but he planted like 800 acres just below Little Rock. As a matter of fact, I was up talking to Bill Bergeson in Minnesota last week, and he's all excited because he wants to go down and measure growth and yield on it because he hasn't been able to find anything.
That's C2I.
Yeah, it's
carbon trees. You know, basically that's their design that they came up with. It mimics the old cottonwood oak interplanting system, and so they use it basically in that manner as well. But it also has quality. The Arkansas side is actually private ownership, and it's a guy who's dealing with carbon, and it's being backed by, he's selling carbon credits to, I don't know if it's a secret or not, Burlington Northern and Duke Power, we're buying his carbon credits or something. Yeah, this comes out of American Forest Industry is what it does. That's where it's registered.
Okay.
Yeah, carbon trees, that's, no. They do that all throughout the alluvial floodplain as
Well, by car.
Okay.
with it. That's their their typical planting style. But in terms of the speed between your shear and your saw, is your saw a lot faster than?
Oh, absolutely, the saw is a lot faster, but
Also,
if you're gonna move it as round wood, especially if you're gonna transport it, how fast, it's what, like, it's like buying a car. You can buy a Porsche that'll go 200 miles an hour, but since most of us, I don't know anybody in the States that's over 75, do you really need it? And the same thing with the shear. The study that we just recently did, we did a DOE project. Steve can talk more about it. You can ask me at lunchtime. A saw head capital cost is about 25 grand more than a shear head, and in maintenance cost is probably 15 grand a year. So yet those are significant numbers, in terms of when you're looking at the big picture. So if we can get away with a shear, and it's enough to meet the productivity of the entire system, I can lay down all 80 acres down in one day here. If I can't move it and chip it and put it in that machine at 10 acres a day, then what good am I getting? I'm not getting ahead. So when you factor in the skidder and the loader and whatever else, the chipper, whatever else the rest of the process is, the shear head, whether you go with just a shear that only cuts this fast versus a saw that goes like that, it may not be an impact your total production.
yeah, I think the key is year-round harvesting and being able to do it. And it's always been a factor of, cutting with your dormant season type of cutting that you've done. And we, at West Baker, we've done it from October, into as late as May. You get into June and July and August and September, and the coppice regeneration is almost nil. It drops off tremendously, so your yield drops off on a per acre basis greatly at that particular time. So maybe there's some variability that exists in that as well, but so far, you're up against that problem.
Okay, yeah, like I said, I was guessing on the windows. Our 2 windows is just, winter was good, summer was really bad. Now, is winter 6 months or 7 months or 8 months, or is it just 3 months? We didn't get into that part of it yet.
So we do have, that factor's built into the AHB sites. We've got growing season and dormant season harvest. And just as a matter of note, the one site that we harvested last year on September 20th, or 20th or 22nd, 100% regeneration. And on my own farm, we're okay June, it's July, August. Now there's probably, and there's variables in that coppicing ability, I think, clonally, and that's pretty subjective on mine, but that's just operationally watching things as we, so there's a bit to be learned in that, but there may be, I agree with Randy, there may be, the heart of the growing season, there may be a window where it just is not going to work, so.
The harvesting the shear blade and between the saw, we saw a lot more damage with the saw to the stump as well in some cases.
So the comment was the shear versus the saw and the damage to the stump, and there's actually a picture in the lower right-hand corner of that poster over there. Again, recognizing that we're using a chainsaw instead of a real saw head, there is concern of a high-speed saw head, if it's maintained well, when it hits the stump, should be really clean. But there's also the concern of when the high-speed saw hits that stump, is it going to jerk it enough to hurt your root system versus a shear that just sort of gradually comes in from 2 sides. So yes, there's issues of which one, the reason shears disappeared, there's 2 reasons shears disappeared. I won't say disappeared. You don't see, for those in the logging business, you don't see shears as much anymore. One, their productivity generally wasn't acceptable enough. But mostly is the shear, what's called shear damage. They do tend to damage the beginning of the butt of the tree. Now, if you're dealing with pulpwood or biomass, that's not an issue, but the saw timber people didn't like it at all. And that's kind of why there's very, very few shears still out there in the logging industry. It's starting to come back because of the reasons I mentioned, the lower cost and the lower maintenance cost. You see them on pulpwood thinning. So if you see a thinning crew, you're starting to see guys that are running shears again because they grab the tree and they don't need to do that much. It doesn't have to be that fast because they're limited by the rest of the system.
Do you think this system is more moving toward a pulpwood system or more moving toward the northeast system where there's 14,000 stems per acre on the case of 1 year harvest each year, an annual harvest?
I'm not sure with the question.
Well, most of the material we were talking about, we wanted cleaner chips, from it, and all of a sudden, if you're in terms of clean chips now with whole tree harvesting material, and with the willow, of course, it's dormant, it's the whole stem that they're harvesting out of the new hollow material. But are we moving more toward a you know, a little bit wider spacing and a little bit longer growing time than we originally estimated.
So the question was, where is the I think he's asking me where the market's going, and from the standpoint of when you harvest this smaller material, the stuff that we harvested, the 3 and 4 inch stuff, you're going to have, it's a shorter rotation, yes, but because of that, you're getting a dirty chip. Everybody understand what a dirty chip is? Everybody on the same page? Dirty chip means it has bark and needles and leaves. It has nothing to do with sand or grit or soil, okay? Dirty chip means it has bark and needles and leaves. You're going to get material with bark and it's a dirty chip. If you want a clean chip, which some of our marketing, some of our industry is asking for, you can't take a tree that big and make a clean chip out of it, because you make a clean chip by removing the bark. And if you try to get the bark off something that big, you're not going to have anything left. Okay, so if you want a clean chip, then you got to start getting up here. You got to get started. And so I think what Randy's alluding to is, while we're trying things here and we're doing this short rotation on 3 years, it could be the market alone drives us back to, you know, here you got stuff on 3 foot spacing, 10-foot row, 3 foot spacing. The market may drive us back to 6 foot spacing and growing it for 8 years and getting that 8 to 10 inch tree. Well, again, you go back to that. I know how to harvest that. I got jobs all over the countryside doing it. It's called, thinning crew. You go out there with a little, 4-wheel fella buncher and mow them down either with a saw head or a shear and a skidder, and you bring them out to the site. You can put that in a flail debarker and get the bark off it and make a clean chip. You're not going to make a clean chip out of something this big around. You're not going to have anything left. And so the market, and again, I'm not the market, but the market's going to determine where we go with this material. Yeah, this is close spacing and we're showing how great a volume we can do. But if they want a clean chip, then we're going to have to go back to 6, if not 8 foot spacing. I think I'm out of time. I know I'm out of time, so.
Yeah.
Thank you very much.
Sam?